Good morning, friends. In the last session of industrial flow metering techniques, we have seen about the applications, then we see about the different properties of the fluid, we have seen the continuity equation, we have seen the parabola, how its parabola is made, we also understand by the magic ratio, and we also understand A1 V1 equal to A2 VT V2. Then we come to the different principles of flow measuring techniques. We found there are 5 major principles. Based on those 5 major principles, we have seen here on the display there's a 36 kind of flow meters. So the first kind of flow meters principle we've seen as a DP type. DP means DP type. Differential pressure means there is a one mechanical structure, then flow will pass through it, then is a tappings P1, P2, and from this P1, P2 we are measuring the differential pressure, and by the differential pressure we are getting the velocity. Then again the same things which we understand in the basics in the last session, that Q is equal to area into velocity. So same funda will applicable here also, but in a different way. So we will see the first DP type flow meter as a very famous and widely used is the Orifice flow meter. So now if you see here the gray part, you are seeing this gray part, this gray part is the orifice. It will look like this. Okay. Sometime it may be like this. So different kind of opening will be here, but how it will work we will see in the next slide. First we understand few more things. This is the flange, this is the orifice sandwich between the two flanges, flange number 1, flange number 2. Okay, and you see here's the tapping points P2, P1. These are the nuts and bolts. These two are the drain ports. So this is about the orifice plate sandwich between two flanges by the nut and the bolt. Then two tapping points P1 and P2, and there's the two drain points. And you see here also this is the weld neck. Okay, here the pipe is welded in this space, right? Few more things I will want to tell you, which is very important. What is the meaning of upstream and downstreams? Means if fluid is flowing in this direction, so this place is called upstream. Okay, and this side is called as a downstream. So we will understand this more when we go to the next slides. So now this is a theory which you can study in different books also, but here are very small things I want to tell you. An orifice is simply a flat piece of metal with a specific size hole bored in it that we have seen. Okay, most orifices are concentric type, but eccentric, conical and segmental designs are also available, which I already shown you like this. Okay, here concentric or eccentric also. This is the meaning of this. Now next, in practice the orifice plate is inserted in the pipe between two flanges. Means this is a one flange, okay, this is the another flange, and your orifice plate is like this. It is inserted between the two. Here is a hole, and this is attached with the nut bolt. This is a kind of orifice plate installation or erection. Most of the time you will see that P1 point, and this is the P2 point, a tapping point, for which we will measure the differential pressure. What is the meaning of differential pressure? Means delta P equal to P1 minus P2, because at P1 the pressure will be high, then when it will go from through this hole, it reduced with the delta P, so it becomes the P2. So this is the meaning of differential pressure. Okay, this is the acting as a primary device. The orifice constricts the flow of liquid to produce a differential pressure. This is the differential pressure. Okay, across the plate. Pressure taps on either side on the plate are used to detect the difference. Major advantage of orifice are that they have no moving parts and their cost does not increase significantly with the pipe size. Now one more thing we will understand here. Here we see the center tapped orifice plate. The orifice plate can be like this also. This is the orifice flange. Then we will have, this is the plate in between, and then it is the pipeline, right? This is the pipeline. Okay, you already seen it's a welded neck, so it's a welded neck. In this figure, this is a central tap, but here it may be like that. Here in the here tapping. The distance between these two tappings are specified by the manufacturer of the orifice. Most of the time it is the 5D, 10D. Now we will see more about this. So now it is very clear here. See, very carefully if you see, you will understand the concept. Okay, if you see here, what you are seeing here. Okay, you are seeing here, this is the pipe, this is the pipe. Okay, you are seeing is the upstream, you are seeing this is the downstream. Okay, because my flow direction is this type. Now this is the orifice plate, this black, this you see, this is orifice plate. When fluid will come here, it will go through it and it go outside. Now you see here, when it is coming here and we go from the constructed place, means continuity equation. A1 V1 is equal to A2 V2. When area is less, then your velocity will be high and there will be a significant pressure drop. But when it reaches to this place, again it will gain the pressure. Okay, again it will gain the pressure, but it will not gain the pressure to equal to the P1. So there is a difference between the delta P. The difference between the delta P is equal to P1 minus P2. Okay, some important thing is the beta ratio. This is called a beta. Beta ratio means what? If you see beta ratio means what? D equal to beta D. So beta means what? Beta is equal to small d by capital D. What is small d? This is the small d. What is the capital D? This is the capital D. Then second important thing is the vena contracta. So you will also understand what is the meaning of vena contracta and what is the reason of the vena contracta. These are the important words when you study the orifice plate. Now in the next slide, we will see how it looks like when we install in a industry. You see here, see orifice plate. Okay, you are seeing here orifice plate. Can you spot it? This blue one. Okay, it's an orifice plate sandwiched between two flanges, and this is the pipe, and this is the central tapping, and here we are measuring the delta P. Okay. Now very important point. If you remember the last session, I told you about the density compensation, STP and TP. Why? Because gases and steams are compressible. So that's why they need pressure and temperature compensation. So here with any delta P type of flow meter, if it's measuring the steam or the any compressive gases or the fluid, then we have to do the density compensation. So with this orifice plate, we are, or delta P type flow meter, we are first measuring delta P, then Simultaneously, we are measuring pressure and we are also measuring the temperature. And these all data will go to the flow computer, and with the square root, we do the square rooting. I will tell you what is the meaning of square rooting or all, and then we will do this density compensation to get the correct flow. So with the Nm cube per hour, N is an important term. Now you see here, what is the meaning of concentric, what is an eccentric, what is a segmental, which we used in a previous slide. So orifice can be like this. In early days, when I used to work, we don't have a very smart transmitters or pressure temperature. So sometimes we doubt our transmitters. That time what we do, we go to the site and we put the manometer. And with the manometer, we try to calculate, and with this calculation, we are validating the instrument. But nowadays, nobody is doing this. Everybody will believe on these instruments. So